Hey everyone, welcome back to my channel. Today we are going to practice MongoDB queries with a collection of housing data. We're going to start with some basic queries and then gradually increase the difficulty. MongoDB is a popular NoSQL database known for its flexibility and scalability. It stores data in JSON-like documents, making it easy to work with varied data structure. As we progress with the queries, you will notice the differences from SQL queries in terms of syntax and other aspects. However, it's important to know some general differences. MongoDB is schema-less, allowing for flexible data models, while SQL databases have fixed schema. In MongoDB, data is stored in JSON-like documents, whereas SQL database use tables and rows. MongoDB use a distributed architecture for scalability, while SQL databases often requires more complex scaling strategies, among many other differences. The software we will use for this video is Studio 3T. There are other options like MongoDB Compass or MongoDB Shell, but it won't be a topic of this video to show you how to download each of these tools. So I ask you to do some research as it is very easy to use them. A great advantage of Studio 3T is that it's not necessary to convert a file to JSON format. For example, if you have a database in CSV format, you can import it and Studio 3T will convert it to JSON format for you. I have already imported the database, but if you right click on the collection, import collection, you will see that you can load the file in any format. So now, in order to explore our database or our collection, we will run some basic commands. So let's start by finding out how many documents our collection has. Remember, a collection in MongoDB is what we refer to as tables in SQL, and documents in MongoDB are like the rows in SQL. So in MongoDB, data is stored in documents, while in SQL, data is stored in rows within tables. So let's run our query. So we have 41,280 documents. And now let's see the first 5 documents from our collection. So the find method is used to query documents from our collection based on specified criteria. In this case, it doesn't have any parameters, but it can accept our parameters like filter criteria, sorting options, and so on. Limit 5 ensures that only up to 5 documents are returned, which is useful to limit the number of results in exploratory queries. And pretty is a method used to format the output of the find query in a more readable and intended JSON format. And each document in this collection represents real estate data taken from different geographical locations. So the ID is a unique identifier for each document. Longitude and latitude are geographic coordinates of the property's location on Earth. Housing median age indicates the median age of houses in the area where a property is located. And that's data typical from population, for example, here population indicates the total population living in the area where property is located. Also within median income, ocean proximity, and so on. So each document encapsulates these attributes, offering a comprehensive snapshot of real estate condition in various locations. So this collection is valuable for real estate analysis, market trends, and so on. So these are the kind of queries we are going to practice. Good, so in this query we should sort all the documents based on the median income, and the sorting should be done in descending order, meaning that the documents with the highest median income will appear first, and for that we will start with the find method. And this find method will be followed by the sort method. That will be responsible of sorting the results, sorting to order the results. And the sorting criteria will be specified as an object where the key is the column we want to sort, which is median income, this column, and that will be the key of our object criteria. And the value will be -1. That indicates the descending order we are looking for. So let's run our query. And the media income is ordered purchase 200 results. And you see how this method organized our data in descending order based on the median income. Alright, so in this exercise we will learn how to filter documents based on range of values using the find method. So let's start with the find method. Leave it. So the find method is used to query documents in a collection. Inside the find method, we pass a query object that specifies the criteria for our search, which in this case is the median income. Which is the field in our database we're interested in. And here we use the GTE operator to set our range. GTE, this operator, it stands for greater than or equal to, and the value is free as the. And then the next operator is LTE, which is less than or equal to, and the value 4. So let's run our query. Here throws me an error. Let's see what happens. Here I forgot the $sign before the operator. Those syntax errors are very common. Remember, we always should put a $sign before writing before each operator. The operator should be with a $sign. So let's run it again. And here we get all the results between 3 and 4. Alright, so in this exercise we will be looking for houses with a median age greater than 30 years and a median house value of less than $200,000. And the first step will be to implement the find method. And this find method in this case will be used to search for documents in a collection that match specified criteria. And inside the find method we pass an object with our conditions, which in this case will be housing median age, So in this object we have two key value pairs. The first pair is for housing median age, which is this column, and the second is for median house value. Here in the housing median age, we are specifying that we want this value, housing median age, to be greater than 30. This operator, GT, $GT, stands for greater than. It's like greater than. This means we will only get documents where the median age of the housing is more than 30 years. Next, let's look at the median house value. Median house value condition. Here, similarly, we are using the LT operator, which is like less than greater GT greater than LT less than, and this condition makes sure that we only get documents for the median house value that is less than $200,000. So when we combine these conditions, we using a comma, MongoDB will return only the documents that satisfy both criteria. So let's run this query in our shell. So there is an error. Let's see what kind of error we got. Oh, I put a comma in the wrong place here. Sorry. Now let's run it again. And there you have it. MongoDB returns all the documents where housing median age is greater than 30 and the median house value is less than $200,000. Alright, so this exercise is about using the group stage to group documents by a specific field and perform some calculation on these groups. It's like the group by in SQL. So here we have a collection of documents that represent housing data, and each document includes fields like ocean proximity, here, and media house value, which is here. And our goal is to group these documents by ocean proximity and calculate the average house value for each group, as well as count how many documents fall into each group. So first we use the aggregate method on our collection. And this method takes an array of stages, which we will define next. And in the first and only stage, here we use the group operator and this is where we define how we want to group our documents and what calculation we want to do. So the structure of this group would be like this. So this ID field specifies the field by which we want to group our documents. Here we are grouping by ocean proximity, which means all documents with the same ocean proximity value will be grouped together. And next we will focus on the average calculation. So this field will hold the result of the average calculation for each group. We use the average operator and pass the field we want to average, which is median house value. This is the field that we want to average. And finally, we have to count the number of documents in each group. For that, we have to implement the sum operator. So first we define the field count. So this field count will hold the count of documents in each group. We use this sum operator with the value 1, which adds 1 to each document in the group. Giving us the total count of documents in each group. So now let's run this query and see the results. And as you can see, we get an array of documents. Each document represents a group with the ID field showing the ocean proximity value, the average house value showing the calculated average, and the count showing the total number of documents in that group. Well, so in this exercise we have to run an aggregation query that does two main things. First, it filters documents based on certain criteria, and then it groups the filtered documents to calculate the average house value. So let's get to work. So remember, the aggregate method is a MongoDB tool for transforming data. So in this case, we need to calculate the percentage of houses with a housing median age greater than 30 years. And that's why we have to use aggregate, because this query requires multiple steps of data processing. As you will see, counting total documents, counting documents with a specific condition, calculate a percentage. This step are or cannot be done with a simple query like find. So simple queries like find are not enough for this complex operation. So first we should filter the documents in our collection. We are looking for houses where the housing median age is greater than 35 years old, and the median house value is less than $250,000. So in order to do this, we will implement the match operator. So in this match stage, we have to filter the documents to pass only the ones that match the specified criteria to the next stage in the pipeline. So remember, the match operator in MongoDB is used to filter documents. Only documents that match the specified criteria will get to the next stage. Alright, so housing median age is the field that we have to check against a condition. Similarly with this field, and in this condition we have to filter documents where housing median age is greater than 30. And median house value, no, not 30, 35. Yes, yeah. Median house value less than . So this ensures that only documents meeting both criteria get to the next stage of the pipeline, if there were any. Alright, now we have to filter, or we have to group the filtered document by the housing media age. And in average house value, we calculate the average value of median house value, which is column from our database. And in MongoDB, when we work with aggregation, when using the group stage, as we are doing here, the ID field serves a crucial role in defining how documents are grouped together and how aggregation operations are applied within these groups. It just defines the grouping criteria and shapes the structure of the output document based on those criteria. It's important to know that this is like a new ID that has nothing to do with the original ID of the original database. I mean, it has nothing to do with the original ID field of the document in the collection. Instead, it determines how documents should be grouped together based on the values of a specific field or expression. So this ID has nothing to do with the original ID. And also, average house value is a new field created by the aggregation, and it contains the result of averaging the median house value of the document in each group. So now let's run our query. And it returns nothing. Sure I have a mistake. And I forgot again the $sign in median house and in less than. Very important in the syntax is to make MongoDB queries. Now let's run again. But I'm getting just one value. It means there is something wrong in our query. Surely it's a $sign. Indeed, there is still a $sign missing here in housing median age. $sign in the query indicates a MongoDB operator. That's the key to understand that syntax is, for example, match, group. Match specifies filter criteria, group indicates aggregation and grouping, average calculates the average value within each group, but also the $sign is used in field names like housing median age and median house value within the group stage. It refers to the value of those fields in the document being processed. This notation is used to differentiate field names from other strings or values. So let's run it again. And here finally we get the right result. So we receive a set of documents showing the average house value for properties where the median age of the house is greater than 35 years and the median house value is less than $250,000. And each document in the result contains ID, the housing median age, that's the value for the group that we define here, and the average house value, the average median house value for houses in that age group in this column. So for example, if the housing median age is 35, the document will show the average house value for all houses aged 35 years that meet that criteria. It helps us understand how the average house value varies with the age of the houses in the specific condition. Good, so with this query we should determine what portion of the total houses have a median age that is more than 30 years, expressed as a percentage. And for that we will start applying the aggregate method to our collection. This method allows us to perform complex operation. So it means we can reshape documents in the collection, add new fields, or modify existing ones. We also can filter out documents based on specified criteria. Then we can group documents by a specified key and calculate aggregate values like sum, average, count, the mean, and max. So aggregate is a powerful tool for performing a wide variety of data operations within MongoDB. And in this case, we will start applying the group operator that will allow us grouping documents together. So this stage groups documents together. The documents are grouped based on the ID field specified here, and this null means all documents in the collection are grouped into a single group. Essentially, it treats the entire collection as one group. Then we calculate the total number of documents in the collection, and for each document in the group, it adds 1 to the total. Since all documents are in a single group, it counts the number of documents in the collection. So this part of the query groups all documents together and counts the total number of documents in the collection. And then in this field, count above 30 years, we will calculate the count of documents where housing median age is greater than 30 years. So here we are calculating the count of documents where housing median age is greater than 30 years. The sum operator is used to add up numbers. In this context, it's summing the results of the condition for each document in the group. This count operator is a conditional statement similar to if-else statement in programming. It takes 3 arguments: the if, the condition to evaluate, then, that is the value to return if the condition is true, and else, that is the value to return if the condition is false. And then the operator GT checks if the first value is greater than the second value. Housing median age, the value of housing median age field is like the current document, and 30 is the value to compare against. And here, if housing median age is greater than 30, it returns 1. And if housing median age is not greater than 30, it returns 0. So putting it all together, the count over 30 years, this field counts how many documents have a housing median age greater than 30 years. It achieved this by summing up 1 for each document that meets the condition 0 for each document that doesn't, and it gives the total count of documents where the housing median age is more than 30. Okay, so after the grouping stage that calculates the total number of houses and the count of houses with housing median age greater than 30. The next part of the query will project the desired percentage. Alright, so remember the project operator in MongoDB is used to reshape documents in the pipeline by including, excluding, or transforming fields. It allows specifying which fields to include in the output, specifying new compute fields, and essentially project operator facilitates the final shaping of the documents that are returned after this preceding stage of the aggregation pipeline. Alright, that's bit said. This ID null excludes the ID field from the output. And this is important for some reasons. For data presentation, often ID fields are not necessary or meaningful for data presentation. They are used as unique identifier within database, but may not provide important information in query results. And the field percentage above 30 years contains the calculated percentage of houses with housing median age greater than 30 years. This multiply operator multiplies the result of the division by 100 to convert it into a percentage. And here is where the operator divides the count above 30 years by the total number of houses to get the proportion of the houses with housing median age greater than 30. Alright, now let's run our query. Oh, we have an error. Let's see what's happening. It's a dollar sign missing here. Let's run it again. So the result is 45%, which indicates that the houses in our collection, 46% of the houses in our collection have a housing median age greater than 30 years. Alright,